Good morning, dear students. I am Dr. Srinivas Bathini, Professor of Chemistry in St. Peter's Engineering College. Today we are going to discuss about the corrosion control method. What is the topic? Corrosion control method. Corrosion control method. So before going to discuss about this topic, so what we discussed in the last two videos. So what we discussed, causes of corrosion, effects of corrosion, and theories of corrosion. What are the theories? Especially wet theory and dry theory. In the dry theory, evolution of hydrogen gas, absorption of hydrogen gas. In wet, that is in wet theory, and in dry theory, the oxidation reaction. That type of things, and color, liquid metal corrosion. So many things are we discussed in the last two videos. And also, so that how the corrosion occur in different metals. Means some of the metals get rusting, some of metal get protective metal, the rust material, corroded metal will protect further corrosion. So all these things we have discussed in that video. So we know till how to form the corrosion, and in that theories we discussed. In the factors, we discussed the factors at temperature, natural, and pure metal or impure metal, whatever that, the causes and damages, effects and factors, we know that till now. But how to control? How to control is important than that one. Controlling is very, very important. Okay, so without iron we can't do anything. We must use the iron material. The iron, steel we must use for the building purpose, for the construction purpose, on the bridge process, or many vehicles or whatever may be. So without the iron we can't live, we can't survive. That is not possible. Without metal, we can't operate anything. In our mobile phones and so metals are there. In computer, metals are there. The good conductive electricity. So how to control the corrosion is important in our day-to-day life. So that is we have. I am going to explain the how to control. The corrosion control method is very, very important. Okay. Mainly proper designing. The designing is important. What is that? Proper designing. Proper designing means the metal should be that. Whatever we want to operate, that proper designing. And use of metal. Use of metal. Use of pure metal. Pure metal. Use of pure metal. Use of pure metal. And using of metal alloys. Using of metal alloys. So alloys, we already studied in intermediate, but the best example are what? Alloys. Alloys are, many metals are there. Brass is a metal. Brass and bell metal, gun metal. So these are some of the examples of alloys. So you have to use the control the corrosion. Controlling the corrosion. If alloys are there, steel is an alloy. If pure metal, iron will get rust. Pure metal, iron will get rust. But where is the steel? Steel containing the iron carbon and nickel, like that. This is the alloy. Mean percentage, different percentage, more percentage mean iron. So here the steel will not get the rust, whereas the pure metal will get the rust. So the alloy. So we have to use the alloy is very, very important. Alloy is the very, very important. And use of pure metal. That impure metal means 100% you have to use. 99% or 98%, but not 70%, 60%. So it is impure metal. So impure metal get rusts very quick than the pure metal. The impure metal will get rust than the pure metal. That is important. So using a pure metal is using of metal alloys and modifying the environment. What is the next step? Modifying the environment. Modifying the environment. Modifying the environment. Mean, for example, in the acid environment is there. In the acid environment, corrosion is occur, the evolution of hydrogen. HCl, acid environment. So, H plus ions take the release of Fe plus 2, formation 2 electron release. These 2 electrons in acid H plus A minus mean 2 electron will take and hydrogen gas will release. Hydrogen gas will release. So, we have to change, modifying the environment. So, modifying the mean, you have to bring to the neutral environment. Bring to the neutral environment. And use of inhibitors. Use of inhibitors. Use of inhibitors. And finally, cathodic protection. Cathodic protection. Cathodic protection and surface coating. Cathodic protection and surface coating. These are the some of the methods of corrosion controls. All these will control the corrosion. So we have to design the proper shape and try to use the pure metal and modifying the environment you have to modify it, and using of metal alloys and cathodic protection and surface coating. So these are some of the important corrosion control methods. Okay. So in this among these 6 so that we have in our syllabus these 2 completely you have to read this one. Cathodic protection and surface control. So we have to see the corrosion control method, that is cathodic protection. Okay, now we are going to discuss about the what? Cathodic protection. Cathodic protection. Cathodic protection. Here, the method of protecting the base metal mean cathodic. What we have to, for example, we want to protect this metal. So we have to call that, this is called the base metal. Base metal. Base metal. The method of protecting the base metal by making it to behave like a cathode. Behave like a cathode. So it should be cathode. Behave like a cathode is called a cathodic protection. What is that? The method of protecting the base metal by making the behave like a cathodic is called the cathodic protection is called the cathodic protection. So this is again through two types. There are two types of cathodic protection. Two types of cathodic protection. So in this, one is the sacrificial anode method, another one is impressed current method. One is what? Sacrificial anode method. Sacrificial anode method. Sacrificial anode method, and second one is the impressed current method. Impressed current method. These two types are involved in the cathodic protection. What protector? The base metal should behave like a cathode. So in this, sacrificial anode method. The anode is sacrificial, mean anode behave like a cathode, and impressed current cathode method. So these methods we have to discuss. Today we have to try to finish the sacrificial anodic protection. Okay, sacrificial anodic protection. So we are going to discuss about the sacrificial anodic method. Okay, this one. Sacrificial anode. Sacrificial anode method. So what is meant by sacrificial anode method? Sacrifice. Have you heard anytime the sacrificial word? We have to sacrifice for our parents. Our mother sacrificed for us. Daughters or son to getting good life. They sacrifice their lives. Our parents sacrifice their life for we want to go very well in the society. So because they are doing hard work for whom? For us. So mean sacrifice their completely life. Mean here that this method mean sacrifice anode. Mean anode and anode becomes sacrifice to protect what? The cathode. That is important. Sacrificial word is very, very important. Okay. In this method, in this protection method, the metallic structure to be protected. What is that metallic structure? It is a base metal. For example, this is a metallic structure. Metallic structure mean base metal. Base metal. This is the base metal. The metallic structure or base metal to be protected is connected by a wire to a more anodic metal. To more anodic metal. This is the anode. What is that? More anodic metal. So this is the base metal. This is the base metal and connected to what? A wire connected to a wire having a more anodic metal. So that all the corrosion is concentrated at this more anodic metal. Mean the rusting. So the rusting mean electrons are transferred. Electrons are transferred. And it will get the rust. Will get the rust. So it will become safe. It will become safe. Mean sacrifice. Here, which one is sacrificed? This one is actually it will not get the corroded. But what is that? The metallic structure when connected to the more anodic by a wire. So that all the corrosion concentrated where? On anodic material. All the concentration is concentrated at this anodic material. So this is called the sacrificial anode method. The more anodic metal itself gets corroded slowly. The more anodic metal is itself gets corroded slowly. While the parent structure actually parent structure is what? Cathode. Parent structure is protected. Parent structure is protected. The more active metal so employed is called the sacrificial anode. More active metals. So more active metal, it is a more active metal. More active metal. So more active metal. So for example, here the base metal is so we have to look the electrode potential value. Electrode potential, that is the E value. So hydrogen is there below hydrogen and above hydrogen. We know that below hydrogen and above. So two metals we have to see that here, for example, the base metal is the iron, we can take. And that this metal, the anodic more active anode metal is, we have to take the magnesium, for example. Magnesium we have to take. Example I am telling. So here this is the more active metal than this one, than iron one. So what happened? It will get slowly. Why? Because it is connected the wire to the base metal. So whenever they get the rust, the electrons are passed slowly and it will get the rust. This is the concept. This is the anodic sacrificial. That is the anodic sacrificial. The metallic structure to be protected is connected by a wire. More active metal. So always the basic metal always connected to the more active metal. For example, it is a less active, magnesium is the high active. Example I am telling. Okay, this is about. So sacrificial anodic method. This one understood? So where it is useful? So that is important. So I was saying that here hulls of ships. Hulls of ships. What is the hulls of ships? So to be protected. So can you draw the ship? The flag. So this is the a big ship in ocean. So here this is called the hull. So it is completely made by iron metal. Iron. So it is a marine water. It is a marine water. Marine water means salty water. Salty water. So what happened? The ships are moving in the marine water. It get rusted. Iron will rust immediately. So what we have to use in that one? The sacrificial anode mean more active metal. We have to use more active metal that is connected to this. Magnesium plates. Magnesium plates. Magnesium or we can say the cheap quality is the zinc. We can use the zinc. Zinc also active metal. Zinc plates that is. Zinc plates. And in the marine water. This is in marine water. The zinc metal or plates are between the connected the ship to the active metal. Ship hulls of the ships. So we have to connect like everywhere here, like connect the zinc plates. Zinc plates should be connected through wire to hulls of the ship. So the hull will protect. So which one is get rusted? Here this plate gets slowly rusted. So after getting, we will remove the empty plate and add the new plate and connect it to the new plates. Like that they are using the ships. Whenever you want to visit the coastal area of any country or shipyard, so you have to observe these things. Okay, so this is about the protection of the one of the hulls of the ship. Okay, and what about the I will tell you in the olden days. So water pipelines also there. Nowadays the plastic PVC pipe we are using, but in the olden days, please draw this picture. In the olden days, underground pipes, water pipes, underground pipe. For example, this is the pipe is going. We are taking the water connection. Here one tap is there. That is okay. This is the land area. Okay. This is the underground. Okay, underground. So here we have to connect the one pipe. What is one rod? One rod, where to tap this rod. So what is this rod? These pipes are made by iron pipes. Iron pipes. Okay? Iron pipes. And what is this? This is the magnesium rod. So the magnesium rod is folded around the iron pipe. So in underground. So what happened now? That electrons are slowly move into the magnesium and it will not get the rust and the magnesium will get the rust. So this is the preventing iron corrosion with sacrificial anode. Preventing the iron pipes in underground pipes. So uses of sacrificial corrosion, underground pipes and ships for hull ships, protection of the hulls of the ships. So these are the some uses we have to can write. And I will tell you so what are the disadvantages? Advantages and disadvantages. Advantages, you know that. What is that? It is a simple method. So it is a simple method. It's a very, very simple method. It has a low maintenance cost. What is the maintenance? Once you have to use this one, the maintenance cost is very cheap. It does not require external power. Any electrical power is required? No electrical power. No electrical power or any power. So mean the cost is very low cost, and it is a simple method. Okay, there is no use of external power. And cathodic interference are minimum. Here the cathodic interference are very minimum. So this is we can write in the advantages. What advantages? Uses and advantages. And disadvantages. What are the disadvantages in this? So in this method, we have to use only one anode. More than one anode is required. More than one anode. In the hulls of ships, we have used 3-4 anodes. Not only one, around the ship we are used. That is the very disadvantage. So more than one anode is required for protecting the corrosion. And it does not work properly in high corrosive environment. It does not work properly in high corrosion environment. For example, in acidic environment, so too much of acidic nature is there, it will not work properly. And must be replaced periodically when it is consumed. For example, in hulls of ships, when it gets in the marine water, so the zinc plates will get the rust. We have to remove always once a while, every 1 month or 2 months we have to repeat this. So periodically, so we have to change it. Anode must be replaced periodically when it is consumed. Corrosion consumed by the zinc plates. So, okay, this is about the sacrificial anode method. Okay, understood? Sacrificial anode. What is meant by sacrificial anode? Once again, what is meant by sacrificial anode? The metallic structure to be protected. The metallic structure base metal is connected by a wire to more anodic metal, so that all the corrosion is concentrated at that metal. More concentrated. This one. So you have to see the pipe. Here this is the base metal. This is a more anodic. You must remember. You have to must write the definition. The definition is very. By looking this definition, you will get the marks. 2 diagrams, 1 definition. The definition is very simple. Once again, the metallic structure, base metal, to be protected is connected by a wire. To more anodic metal, so that all the corrosion is concentrated at this more anodic metal. Okay. So this is about the sacrificial anodic method. Okay, thank you. Tomorrow we will discuss the that is impressed current cathode method as well as surface coating. Okay, thank you.